in this video, we are going to see a problem on DLS, that is Development of Lateral Surface of a cylinder. For that, here we have a question. It is given that a cylinder 30 mm diameter and 50 mm long stands vertically on its circular base. It is cut by an AIP, that is auxiliary inclined plane, inclined at 45 degree to HP and bisecting the axis of the cylinder. Draw sectional top view, front view and DLS of the truncated cylinder. That is, we have to draw the development of lateral surface. For this, truncated means cut cylinder. Now, first I'll start explaining the conditions. Since the solid is a cylinder, I'll draw the diagram for it. I'm drawing a rough diagram. So here is a cylinder. It has a circular base and circular top. Then this is the axis of the cylinder. And when the cylinder is kept on the ground, like here on its circular base, in that case from the top view we are going to see the circle, and from the front this cylinder will look like a rectangle. So I will start with the initial condition first, that is drawing the cylinder in top view and front view. Now the diameter of the cylinder is given as 30 mm. A cylinder 30 mm diameter and 50 mm long. So 50 mm long means that is the height of the cylinder. In the top view we are going to see that circle. Now as the diameter is 30 mm, so radius is 15. Drawing a right circle. Next, in case of cylinder, we have to convert it or divide it into 8 parts or 12 parts. Here I am dividing it into 8 parts. For that, I have to take the angle as 45 degree in order to divide the circle into 8 parts. Similarly from the other side. Now after dividing this circle into 8 parts, I'll give the notations. Then I'll plot this in the front view. In the front view, the cylinder will appear as a rectangle of height 50 mm. So measuring 50 mm is the height of the cylinder. Drawing a light horizontal line. Giving the notations in the front view as well. So here is point 1. Here I'll say it is 1 dash, 1 dash. Then 2 and 8. So 2 dash and 8 dash. Next 3 and 7. 4 and 6. At last 5 dash. Now this cylinder is cut. The condition is given in the question. I'll read it. It is cut by an AIP, that is auxiliary inclined plane. Inclined at 45 degree to HP, it means this is the cutting plane. Inclined at 45 degree to HP, it will be seen in VP and bisecting the axis of the cylinder. For that, I'll take the half of the axis, that is, since it is 50 mm height of the axis, I'll take half of it, drawing a light horizontal line through it. Now the cutting plane should pass through this point, that is bisecting the axis, inclined at 45 degree. So I'll measure the angle 45. Now I'll draw a line inclined at 45 degree, which is the cutting plane, passing through the midpoint of the axis, that is bisecting the axis as mentioned in the question. This light line indicates the cutting plane. And now we have to cut the cylinder into two parts. As we see here, this line is dividing the cylinder into two parts. One part has to be removed, other has to be retained. So here in this question it is mentioned we have to draw the sectional top view. For that we are looking from top. It means the portion which is above the cutting plane, that has to be removed, because when we are taking the section we have to remove that portion which is closer to the observer. So I'll remove this portion, and remaining whatever is there we have to make it dark. First I'll make this cutting plane dark. Cutting plane AA dash. So the bottom portion of this cylinder is retained, that has to be made dark. So this much part of the cylinder is visible, and here whatever the generators are there, they will be kept light, because in case of a cylinder these are the imaginary generators which we are taking. So only the outline will be dark, the generators we have to keep it light. Next, here as we see, the cutting plane is cutting the cylinder across the generators. So I'll give the notations accordingly, like where it is cutting the generator 1 dash 1 dash, I'll call that as A dash. Where it is cutting 2 dash 2 dash, that will be B dash. Next, similarly C dash, D dash and E dash. Where it is cutting edge 6 dash 6 dash, that will be F dash. For 7 dash 7 dash, that will be G dash. At last, where it is cutting 8, that will be H dash. So these are the points which I am getting when the cylinder is being cut by the cutting plane. Now for the sectional top view, we have to draw the section lines over here, and section lines are inclined at 45 degree. When we are looking from top, this entire circular portion will be visible. It means from the top view, if we are looking this cut cylinder, it will look like a circle, and with sectioning lines inclined at 45 degree. So this is the sectional top view, in which the entire circular base is visible, and this circle is actually an ellipse, because the true shape is not a circle as the cutting plane is inclined. If this cutting plane would have been parallel to the base, then we would have got circle as the true shape. But since here the cutting plane is inclined, so we would be getting an ellipse. And if we are looking from top, now this circle is visible, so it means this is the apparent shape which is visible in the top view. Next, After completing the front view and sectional top view, in the question it is mentioned we have to even draw the DLS, that is development of lateral surface, for this cylinder. And for that purpose, since if we are having a cylinder and when we want to draw the development, we have to open this cylinder in such a way that this complete cylinder, when it is opened, it will be in the form of a sheet. Like when we want to form a cylinder, previously it will be in the form of a sheet, and then when that sheet is rolled, we are going to get a cylinder something like this. That if I am rolling this sheet, here we are getting this cylindrical portion. So it means in order to get the cylinder, we have to open this cylinder and we are going to get a complete circumference. So for the development of a cylinder, here as the diameter is 30 mm, so we have to calculate the value of pi d, and that pi d value, it is pi into 30, and it comes out to be 94.24 mm, which we can take it as 94 mm. So this much is the circumference of the cylinder. Now that circumference needs to be plotted here. For that I am drawing a light horizontal line. A light vertical line. Next, I'll take this point as the reference and measure 94 mm over this. Here I'm marking 94 mm, and then I'll draw a light vertical line. So in short, this is the circumference of the cylinder, which is of 30 mm diameter. When we are opening it, it will be in the form of a sheet. Next, we need to divide this circumference into 8 equal parts, like we have divided the circle into 8 equal parts. Similarly, this rectangle also needs to be divided, and for that purpose, here I'll show a method in which, taking this point as the reference, we have to take an acute angle. It could vary from 10 degree to 30 degree, anywhere in between you can take any angle. Here I am taking the angle as 20 degree. Acute angle between 10 to 30, I am taking the value as 20. Now drawing a light line through it. Next, in order to divide this rectangle into 8 equal parts, first I'll divide this inclined line into 8 equal parts. For that, I have to take the distance of 1 centimeter, taking the distance as 1 centimeter, and then plotting it on this inclined line, dividing it into 8 equal parts. Next, after dividing it into 8 equal parts, here we need to join the last division with the last division here. That is, I am connecting these 2 points with the help of light line. Then we have to move parallel to this line. So here I have drawn parallel lines. Next, I'll draw vertical lines through these points. Next, here I have divided this rectangle into 8 equal parts. The method I have explained. I'll give the notations to it. This will be 1 double dash, 2 double dash, 3, 8 and the last division will be 1, because when we are starting with the point, then we have to end also at the same point, then only the solid will close. Now here I have to see which are the points which we are getting when the cutting plane is cutting the cylinder. So here if we see, the cutting plane is cutting edge 1 dash 1 dash at point A dash. So this will be projected up to 1 double dash with the help of light line. And this same point will be projected up to the other point 1 dash. So here is point A double dash and A double dash. Next, B and H. B dash is on 2 dash 2 dash. B double dash, and on this same line there is H dash as well, cutting 8 dash 8 dash, H double dash. Then we have C dash which is on 3 dash 3 dash. This gives me the point C double dash, and on this same line there will be G dash cutting 7 dash 7 dash. So projecting it light, where it is cutting 7 double dash 7 double dash. That will give me G double dash. Then for D and F, D is cutting edge 4, F is cutting 6. So I'll bring this point up to 4 double dash. That will give me D double dash. And point F dash is on 6 dash 6 dash. So extending it up till here. F double dash. Then E dash is on 5 dash. So E dash is projected on 5 double dash 5 double dash. That will give me the point E double dash. Now these are the points which we are getting when the cylinder is being cut with the help of a cutting plane. Then these points needs to be joined in order in proper sequence so that we get the development. So I'll join them with the help of a French curve. This needs to be adjusted. So I'm drawing a curve here with the help of a light line. With the help of a light line. Then I'll join the other points in the proper sequence. Similarly here. So now I'll be making this curve dark. So here I have made the outlines also dark, and this is the curve which we are getting when the cylinder is cut with the help of a cutting plane. And here is the development of this truncated cylinder as it was asked in the question. Next, I'll give the dimensions to it. The cutting plane inclined at 45 degree, to HP seen in VP. The diameter of the cylinder 30 mm. Height of the cylinder 50 mm. And then the circumference pi d, that is 94. And with this we complete the problem.